Okay, here we go. We're going to take another shot at this. This time we are going to look at it from our kinematics or UAM approach to things. That means that anything that is going upwards is going to be considered positive. Anything that is going downwards is considered negative, and we are not stuck with just going in one direction. We can go up and back down all in one shot if we wish to. I am, well, to be perfectly honest, the very first part here is just like the other part. Since they are asking about at the top, we actually do just go for the first part. This is my initial position. This is my final position for the first look at things, because I am asked to figure out what the maximum height is. So as far as what we know, my initial velocity is equal to 23 meters per second, and it is positive because it is upward. My acceleration in the y direction is equal to a negative g, which is negative 10 meters per second squared, and it is negative because it is downward. At the top of my flight, my final velocity is going to be equal to 0. We are trying to figure out what was the maximum height on the way up. This is a change in the y direction, which is going upward, so it's going to be a positive value. So what are we finding here? We are finding delta y. All right, so looking at our kinematic equations, we have an initial velocity, a final velocity, and we would like to figure out what the displacement is. We can go straight to the fourth equation here and figure that out without needing anything else. All right, so the fourth equation, v final squared is equal to v initial squared plus 2 times the acceleration in the y direction times the change in y. I'm going to solve this for change in y. So I'm going to take my initial velocity and subtract it. Then I'm going to divide by 2 and divide by the acceleration in the y direction. So I have final velocity squared minus initial velocity squared divided by 2 times the acceleration in the y direction. Since I know that one of these is 0 at this point, I will cross it off. And so I have the negative of my initial velocity squared, 23 meters per second, that is getting squared, divided by 2 multiplied by our acceleration of 10 meters per second squared downward, which is negative again. The negatives will go away because we do know that this thing is supposed to end up higher than it was before. I tend to work the bottom of problems when I've got the pink calculator, then hit the 1 over x button to put it into the denominator, and then continue with the top. So 2 times 10, oh, that's just 20. All right, so 23 squared, and I'm going to ignore the negatives because I'm going to put a negative here, I'm going to put a negative there. Divided by 20 is 26.45 meters. Now please remember, they wanted the total height. We called it before capital H. We called this one, fine with me if that one's called H, and this big thing over here, let's call it H. We just figured out delta y for part 1. Delta y for part 1. So again, it's 26.45 meters plus the height of the building, 55 meters. Okay, same exact answer as before, 81.45 meters. What speed did the cannonball strike the ground? Okay, this time around I am going to go with the entire flight. So this was my initial location for part 1. This is also going to be my initial location for part 2, and this down here is going to be my final location for part 2. Alright, so now with part 2, Okay, so this was all part 1. This is all part 2. My initial velocity is still 23 meters per second. My acceleration in the y direction is still negative g, or negative 10 meters per second squared, which is what positive physics is set to use. Remember, you can get away with 10 on the AP exam. The next thing that I know is how far downward it's going to be. My delta y, my change in the vertical direction, is going to be negative, because it's going downward, 81.45 meters. And they would like to know, what speed does it hit the ground? V final equals what? All right. I got this. I'm back to where I was last time. I'm still going to use equation 4. So V final squared is equal to V initial squared plus 2 times my acceleration in the y direction multiplied by my displacement in the y direction. So my final velocity is equal to the square root of that stuff. The initial squared plus 2 acceleration in the y direction, displacement in the y direction. And the initial velocity was 0. So I'm going to ignore that. So 2 times negative 10 meters per second squared multiplied by a negative 81.45 meters square rooted, and we end up with 2 times, well, the negatives are going to cancel, 10 times 81.45. It equals, take the square root, 10.07. The final velocity is equal to 10.07 meters per second. That does not sound like what we found before. We had 40.4 meters per second before. I want to double check this real quick. My initial velocity was not 0. Okay, I'm sorry. Let's back up a smidge here. My final velocity is equal to my initial velocity squared, which was 23 meters per second. I got to square that. Then I'm going to add 2 times my, well, I don't need parentheses yet. Actually, I do need parentheses. My acceleration is negative 10 meters per second squared. My displacement was, again, negative 81.45 meters. All right, so this time around, I know, well, let's see. 2 times 10 times 81.45 equals, that's the second term, plus 23 squared equals, this is what's inside my radical, square root that, 46.45. Okay, now we agree. 46.45. But I have to be smarter than my calculator. And that means I have to recognize that what comes out of a radical is either positive or negative, and this one is negative because it is going downward. Now they did ask for speed, so 46.45 is fine, or 46.5, just because they asked for speed. What was the cannonball's total flight time? Last thing I want to do here, we've got lots of variables. We need a flight time. Let's just use VVAT. So I'm going to go up here since I'm running out of space. Final velocity is equal to initial velocity plus acceleration in the y direction multiplied by time. I am using the entire flight path, so my time is equal to final velocity minus initial velocity divided by acceleration in the y direction. Final velocity is negative 46.5 meters per second minus my initial velocity of 22, ran out of space, meters per second, divided by my acceleration, which was negative 10 meters per second squared. So my time 46.5 negative minus 22 equals, divided by 10 negative, is 6.85 seconds. All right, we have a minor discrepancy with the other one, which was 6.35, and I'm not sure which one's right. Okay, this is where you plug it into the thing and see if it works. 6.85 seconds. All right. It is a different approach. The negatives are done differently. It still works similarly. Their approach is acceptable. The equations on the formula sheet are more like these ones. So usually we stick with these. All right, thank you for watching.